Okay, so I want to go through some problems in number 2 on worksheet 6.3. Again, like before, if you want to try these on your own first and then check out this video if you find you're running into trouble, or if you want to check a little bit of this video out, pause it, try it on your own, up to you. But I'm going to go through a significant number of these just so you guys can get the hang of it. Okay, so notice here, what I want to fill in for all these problems is for A, I'm either going to put positive or negative 1. So basically you're going to have plus or minus the trig function. And B has to be an acute angle. So the first thing I want to figure out is where the heck is tangent 512? So it's more than one revolution, because one revolution would be 360. Well, how much more of a revolution is it? Well, if you subtract 360 from 512, you get 152. So tangent of 512 is coterminal to 150, or 512 is coterminal to 152. So let's draw 152. Again, it would, if we are drawing tangent of 512, I'd draw one full revolution and 152 more. I don't need to do that. I just need to know that it's the same as doing tangent of 152. So 152 would be here in quadrant 2. And so doing the tangent of 152, kind of like we did in the last problems that we were just looking at, is dropping this altitude and creating the triangle. What is this angle here? Well, it's going to be the difference between 152 and 180. So this will be 28 degrees. So that gives you your acute angle. So I am really doing the tangent of 28 degrees. So B is 28. The question is tangent going to be positive in quadrant 2? Well, in quadrant 2, the y is positive, but the x is negative. So in fact, the ratio will be negative. So you can't just say tangent of 28. You have to say negative tangent of 28. So in this case, A would be negative 1 and B is 28 degrees. Okay, let's do another. Let me just move this up a little bit. Let's do, the next one we have is cosine of 244. That happens between 0 and 360. So let's just draw where 244 is. It's going to be in quadrant 3, because it's between 180 and 270. And again, we want to find that angle that's formed between the terminal side and the closest x-axis, because that's the angle we'll be looking at. Okay, so we would, to find that angle, it would be 244 minus 180, which is going to be 64 degrees. So that's going to give us our A value. So we're saying so far cosine of 244 is equal, I haven't done the A value yet, but it's going to be equal to cosine of 64. So now the question is, cosine of 60, cosine or a trig function of any angle of a quadrant 1 angle is always going to be positive, because everything's positive in quadrant 1. So the question is cosine 244, would that be positive? Well, since it's in quadrant 3, where x is negative, r is always positive, then it's going to be negative. So I need A to be negative 1, and then B is 64 degrees. Okay, let's see. Oh, C, we're getting a little more interesting here if we move to C. So let me move everything up a little bit. Because notice C, unlike the other two, where the trig function was the same on the both sides, not the case here. Okay, so let's look at this. We've got sine of 213 degrees is what in terms of cosine of some acute angle. Okay, so my advice here is let's first find what sine of 213 would be in terms of sine of some acute angle, just like we did in A and B. So let's pretend we were just finding A sine of B. All right, so as a first step, so 213 is in quadrant 3, And again, we're interested in that angle between the terminal side and the closest x-axis. So that angle here would be 213 minus 180, or 33 degrees. So right now we have sine of 213 degrees is equal to sine of 33, but then remember we have to think, is it going to be positive or negative in quadrant 3? Since y is negative, it will be negative. Well, now how can I write, instead of writing sine, write cosine? That's where the identities come in. Because remember, and we're just going to keep the negative 1 in front, sine of 33 is the same as cosine of 90 minus 33. So this will be equal to negative cosine of 90 minus 33 is going to be 57. So there you have it. So in this case, A was negative 1 and B was 57. So again, the more we do these problems, the more those we get familiar with those new trig identities. Okay, let's, actually I'm confident you can do D. I'm debating because there is one thing about D. No. Let's, I think you can do D. Someone has a question, they can ask me in tutorial. I think it's pretty straightforward, but, or email me if you have a question about D. I can do D if people have a question, but it's very similar to C. But now let's get to something a little more interesting, because you notice at, for this next one that we're doing, which is E, people are like, 2? Is that 2 degrees? No. There is no little degree symbol there. So this is in terms of radians. So actually, let me back up for a second. This is going to be very important for you to think about. So when we talk about radians going around the unit circle, or going around doing one revolution, and what the radians are at what the radian measure is on the axes, we've got 0 here. Remember, 90 is pi over 2. 180 is pi, and 3 pi over 2 is 270, and then back to 2 pi. Well, it's helpful to know what about this is, and what each of these are in terms of decimals. 0, of course, is 0. Pi over 2 is about 1.457 radians. Pi, you all know, is 3.14. 3 pi over 2 is about 4.7, and 2 pi is about, which I feel like people will know, 6.28. So keeping that in mind, that will help us figure out what quadrant we're in when they're not nice radians like 2. Okay, so now let's move things up just a bit. And I'll keep this up here. All right. So now looking at this next one, how are we going to do sine of 2 equals A sine B? Well, 2, this is actually very similar to the early ones. We're just in radians here. So 2 is going to be in quadrant 2 because it's greater than 1.57, but less than 3.14. So I'm interested in this angle here in terms of radians. So instead of doing 180 minus something and getting a nice number, I'm just going to leave this as 180 in terms of radians, which is pi, minus 2. So doing the sine of 2 is the same as doing sine of pi minus 2. And then we just want to ask ourselves, okay, pi minus 2 is going to be an acute angle. Is sine of 2 positive or negative? Well, since it was in quadrant 2 where y is positive, it should be positive. Therefore, A is going to be positive 1. So this is going to be positive. So A is 1 and B is pi minus 2. All right, I'm going to skip F for the time being because I want to because I want you to try that. And then let's look at something like G. So actually, I want to do a different color here. Let's erase that. Let's do red. Okay, so cosine of 4, what is that in terms of sine? Okay, 4 is greater than 3.14 and less than 4.7. So we're going to be in quadrant 3. So to find that acute angle here, to find this angle, I'm going to do, normally I'd do the angle minus 180. In this case, I'm going to do the angle, which is 4 minus 180, which is pi in terms of radians. So I'm going to say, remember, we have to do this intermediate step because first we have to find it in terms of cosine of acute, then we can deal with changing it to sine. So cosine of 4 is going to be equal to cosine of 4 minus pi. But remember, be careful because cosine of 4 in quadrant 3 would be negative. So I've got to add a negative here. All right, well now let's just change this in terms of sine using the not Pythagorean, my goodness, God, it's getting late. The cofunction identity. So minus sine of, normally we'd say 90 minus in degrees, but we're going to say pi over 2 minus 4 minus pi, minus that acute angle. The parentheses are important. So this is going to be negative sine. Well, it's going to end up being pi over 2 minus a negative pi, which is 3 pi over 2 minus 4. Pretty neat, yet complicated. So A would be negative 1, and B would be 3 pi over 2 minus 4. Okay, try H.